Hi guys, welcome back. I'm Mr. Mustafa Sha'lan and this is Chemistry for Senior 2. Our syllabus contains of two units. Unit 1 is talking about the atomic structure and Unit 2 is talking about the periodic table. Firstly, let's talk about the chapter 1, which is the structure of atom and atomic structure, and this is a historical development of the concept of atom. Firstly, we're going to talk about the Greek philosophers, and the Greek philosopher defined atom as any piece of matter can be divided into smaller parts, and each part can be subdivided into smaller parts which cannot be divided anymore. This one is called atom, and the word atom is divided into two syllables. The first one is A and the second is tom. A by Latin means not, tom by Latin means divided. So the word atom means not divided, and this is the meaning of atom. After that, one of the Greek philosophers, which is Aristotle, and Aristotle refused the idea of Greek philosophers about the atom. He supposed that all matter composed of four constituents, which are air, water, dust, and fire. And he postulated that the cheap metals, such as iron or copper, for example, can be changed into precious one, like gold, by changing the percentage of the four constituents. After that, the third scientist, which is Boyle. Boyle refused the idea of Aristotle, and he is the first scientist who defined the element as a simple pure form of a substance which cannot be analyzed into simple one by normal chemical methods. After that, we have Dalton, and Dalton atom, he is Dalton is the first one who put a theory about the atom, and he supposed that the substance consists of very small particles which called atom. Every element consists of very small dense atoms which cannot be divided. Number 3, atom is the same element are identical, and the atom of different elements are different. By 19th century, scientists had accepted the idea of element consists of atom, but they knew very little about those. After that, we have Cathode Ray Experiment, and this is caused the discovery of electrons. But we all know that all gases under normal condition of pressure and temperature do not conduct electricity or electric insulators. But if the glass tube evacuated from gas to decrease its pressure to reaches 0.012 to 0.001 millimeter mercury, this gas becomes good conductor of electricity. And if the potential difference between the two poles increases up to 1000 kilovolt, a flow of invisible rays are emitted from the cathode, causing the glowing of the wall of the tube behind the anode, and this one are called cathode ray. Cathode ray have 6 properties. The first one, those are consist of tiny particles, have a mass and have a velocity. This is number 1. Number 2, they transferred in a straight line with a glowing glass facing the cathode. Number 3, they are negatively charged particles. Number 4, they have a thermal effect. Number 5, affected by electric and magnetic field. Number 6, and which is an important property, cathode ray do not change by changing either the cathode material or the type of gas, which proves that cathode ray takes part in all structure of all substance. After that, we have Thomson atom. Thomson concluded from the last experiment, which is Cathode Ray Experiment, that the atom is homogeneous sphere of positive electricity. Inside these atom embedded a negative charged particles which are electron. But the number of negative electron equal the number of positive charged particles, which make the atom totally electrically neutral. After that, we have Rutherford experiment. Rutherford, assisted by Geiger and Marsden, performed a famous experiment according to the suggestion of Rutherford by the following apparatus, which is this one. He allowed alpha particles to hit a metallic plate linked with zinc sulfide. Why especially zinc sulfide? Because zinc sulfide glows when it hits with alpha rays. After that, he received the emission from the alpha source to get on this plate. He observed 3 observations, and according to this observation, he put his result or his conclusion. The first one, most of alpha particles appear in the same position before putting the gold foil. And this leads to, or Rutherford concludes, that the atom is a space which is not solid as Dalton and Thomson explained. Number 2, a very small portion of alpha particles reflected in another direction or in the opposite direction, which means that the atom has a very small part with a very small volume but with high density. High density means high mass. Number 3, some flashes appear on the sides of the first site. This means that the dense part which found in the middle, which concentrated in its most mass, have the same charge with alpha particles. Since alpha particles are positively charged particle, therefore the high mass object is positively charged particle, which is known as nucleus after that. So the structure of the atom according to Rutherford. Rutherford was the first scientist who stated the concept of atom according to the atomic structure according to an experiment. But before we talk about the structure of atom according to Rutherford, we have to know some expressions. The first one is the atomic number. And the atomic number refers to the number of positive protons found inside the nucleus, or the number of negative electrons inside the energy levels for the atom in normal condition. Number 2, the mass number, which is the summation of number of protons and neutrons inside the nucleus. Number 3, isotopes, and they are the different forms of atom which have the same atomic number but differs in the mass number. For example, hydrogen have 3 isotopes which are hydrogen, deuterium and tritium. According to Rutherford, the structure of atom is: atom, although it has a very small size, but it has a complicated structure that resembles the structure of the solar system, in which the electrons rotate around the nucleus in the orbits. This is number 1. Number 2 is talking about the nucleus, and he said that, or he supposes that, the nucleus is much smaller than the atom, located in the center of the atom, and it's positively charged. There is a big space between the nucleus and the orbits at which the electrons rotate. So most of atom is space, and most of the mass is concentrated inside the nucleus, and the mass of electrons are neglected relative to the mass of protons and neutrons. For electrons, he supposed that electrons have a negligible mass compared with the mass of the nucleus, as we said from a while. Number 2, the number of electrons equal the number of protons, so the atom is electrically neutral. Number 3, electrons revolve around the nucleus in a fixed orbital, as the electrons are affected by 2 forces which are equal in strength but opposite direction. These 2 forces are the force of attraction of the nucleus. This is number 1, and the second one is the centripetal force or centrifugal force resulted from the rotation of electrons around the nucleus. After that, Bohr atom. Bohr postulates the first one. He says or postulated that a positively charged nucleus exists in the center of the atom. Number 2, atom is electrically neutral, as the number of positive protons equal the number of negative electrons. Number 3, electrons revolve around the nucleus in an orbit due to the centripetal force and the attraction forces which are equal and in opposite direction. Number 4, electrons orbit the nucleus at a rapid movement without gaining or losing any amount of energy. Number 5, electrons orbit the nucleus only in a definite allowed energy level, so they cannot be found in an intermediate distances, which means that if we have K, L, M, N, O, P, Q energy level, K energy level and L energy level, which are the first and second energy level, it's forbidden for being an electron between K and L. Number 6, each electron of the atom has a definite amount of energy, which is dependent on the distance between the energy level and the nucleus. This energy increases as the radius increases, which means that the energy of the energy levels, or the energy of electron, which are equal, this energy increases as we go further from the nucleus. It was found that the maximum number of energy level in the heaviest atom in the ground state, which is mean unexcited atom, is only 7, which symbolized by K, L, M, N, O, B, Q. Each level has an energy expressed by the whole number called principal quantum number. For example, the first energy level K, the principal quantum number is 1. The second energy level, which is L, the principal quantum number is Q. If an atom is excited by heating, which is mean take a quantum of energy, the electric discharge of electron transfer to higher energy level. Agree the absorbed quantum. The excited electron is higher energy level is than unstable. So it returns back to the original level, losing the same quantum of energy, which it gained during the excitation in the form of radiation, have a definite wavelength and frequency. What does this point mean? For example, if we have an electron found in K energy level, and after K energy level we have L energy level. When this electron, which is found in K, is transferred to L energy level, that means that it gains an amount of energy which equals the difference between the two energy levels in energy. So this amount of energy is called the quantum. When the atom, which is in ground state, transferred the electron, its outermost energy level electron, to the higher energy level, it becomes an excited atom. This excitation process occurs when an atom gains an amount of energy, which is called the quantum. When this atom wants to return back to its original condition, which is normal condition, which is ground state, the electron loses the same amount of energy, which is quantum, causes the radiation of a photon or energy in a form of light, which has a specific wavelength and frequency. So we have some remarks to be noticed. Number 1, the definition of quantum. Quantum is the amount of energy gained or lost when an electron jumps from an energy level to another one. Number 2, the difference in energy between the energy levels are not equal. The difference of energy decreases as we go further from the nucleus. This means that the quantum energy required to transfer an electron from the level to another are not equal. Number 3, the electron doesn't move from an energy level to another unless the energy absorbed or emitted are equal. After that, the excited atom. Excited atom is an atom that acquires an amount of energy sufficient to transfer its outermost energy level electron from the original energy level to higher one. Bohr had 3 advantages, which are: firstly, he explained the hydrogen atomic spectrum correctly. Number 2, he introduced the idea of quantum. Number 3, he proved that the electron during that electrons around the nucleus, during the rotation around the nucleus, in ground state do not radiate any amount of energy, so they will not fall back to the nucleus. After that, the disadvantages. Firstly, he failed to explain the atomic spectrum for any element except hydrogen, which is the simplest in electronic configuration. Number 2, he considered that the electron has a negatively charged particle only, and he didn't consider that it also had the wave properties. He postulated that it's possible to determine precisely both the speed and location because the apparatus used will change them, either speed or location, which means that Bohr postulated that he can determine the speed and the location precisely at the same time. But experimentally, it's impossible. Why? Because the apparatus used to determine the speed or the location won't give the result accurately. Number 3, he described the electron when moving in the circular planar orbit, which means that the hydrogen atom is a planar. Later, we was confirmed that the hydrogen atom has 3-dimensional coordinates. Bohr theory, the atomic spectrum, studying and explaining the atomic spectrum was the key for the atomic structure. And by the way, he deserved the Nobel Prize at 1922 because of the explanation of hydrogen and the concept of atomic spectrum. Atomic emission spectrum. Number 1, by heating gases or vapors of substances at high temperature, by heat or electricity under low pressure, it produces light. By using the spectroscope, we define that this light consists of fixed number of colored lines called line spectrum. Line spectrum by experiment proved that the spectrum lines differs from one element to another one, like a fingerprint. But according to the disadvantages of Bohr, a new scientists put a principle to solve this problem or solving these disadvantages, which is the modern atomic theory. The modern atomic theory have principles, which are 3. Number 1, the dual nature of electron. Number 2, the Heisenberg uncertainty principle. Number 3, finding the mathematical expression which describes the wave motion of electron, its shape and its energy. Let's start with the dual nature of electron. The experimental data show that the electron has the dual property, which are its material particle, as Bohr says, and it has also wave properties. The scientist who put this assumption, which is de Broglie, and he put de Broglie principle, which states that every moving particle, such as an electron around the nucleus, is associated with or accompanied by a wave motion, which is same properties of light. So the matter wave motion differs from electromagnetic wave in. Let's compare between the matter wave and electromagnetic waves. Matter wave, they are not separating from the body, they are attached to the body. Number 2, their speed are not equal to the speed of light, while electromagnetic wave are separated from the body and their speed are not equal to the speed of light. After that, Heisenberg uncertainty principle. Heisenberg uncertainty principle states that it's impossible practically to determine both the position and velocity of the electron exactly at the same time. But we can only say that it's probably to, with a greater or lesser extent, to locate an electron in this position. This is to speak in terms of probabilities, seems to be more precise. The wave equation for the motion of electron inside the atom by Schrödinger, or to be more accurate, Schrödinger wave mechanical theory. He applied the idea of Planck, Einstein, de Broglie, Heisenberg, so he showed that it's possible to determine the allowed energy level of the electron and define the origin on space around the nucleus at which the electron rotates. Number 2, the electronic motion around the nucleus has the wave properties. Therefore, the position to use the term of electron is described by any orbital and he put another terminology, which is electron cloud. Electron cloud is an area or space around the nucleus where there is a great probability for finding the electron in all direction and all position. The difference between the orbit and the orbital concept according to both Bohr and Schrödinger. Bohr state that the orbital is a circular path. The orbital is a circular path with a constant radii, while Schrödinger stated that the electron cloud used to describe any orbital, and the electron cloud, the region of the highest density of the dots represented by the region of high probability of finding the electron. The mathematical solution of the Schrödinger equation introduced 4 numbers, which are called quantum numbers. What about those 4 quantum numbers? Those numbers define the volume and space where there is a maximum probability of finding the electron. Besides, they define the energy, shape, and the direction of orbitals. Those 4 quantum numbers are the principal quantum number, subsidiary quantum number, magnetic quantum number, and spin quantum number. Principal quantum number. Principal quantum number firstly introduced by Bohr. The order of principal energy levels is the number in the heaviest known atom R7. Number of electrons required to fill these energy levels equal to times the square of the energy level, 2n power 2. The first energy level, for example, according to this rule, is saturated by 2 electrons. The second energy level is saturated by 8 electrons. The third energy level 18 electrons, and the fourth is 32 electrons. But this rule is not applied to the last 3 energy levels, which are O, P, Q. However, the atom becomes unstable if an electrons exceed 23 electrons at specific energy level. Subsidiary quantum number used to detect the number of sublevel in each energy level. The energy sublevel take the symbol S, P, D, F, and this is known by a scientist Sommerfeld. When he used the spectroscope, which had the high resolving power, he found that the signal line represented electron transition between 2 different energy levels is consisted of a number of fine spectral lines, which represented electron transition between the very near energy levels, which are sublevels. But notice that the number of energy levels mean the number of energy sublevel equals the number of energy sublevel. That means that K energy level contain 1 energy sublevel, which is 1s. The second energy level L consists of 2 sublevel, which are 2s and 2b. The third energy level consists of 3 energy sublevel, which are 3s, 3b, 3d. Fourth energy level consists of 4 energy sublevel, which are 4s, 4b, 4d, 4f. Fifth consists of 5, 5s, 5b, 5d, 5f. The sixth consists of 6 energy levels, which are 6s, 6b, 6d, 6f. And the seventh consists of 4, which are 7s, 7b, 7d, and 7f. Energy sublevel are not equal in the same level. F has the highest energy, D lower, B lower, and S is the least. The energy of the same levels but different energy levels are also differs. For example, 4D has higher energy than 3D. Magnetic quantum number. Magnetic quantum number detected by Zeeman, who supposed that the spectral line of strong magnetic field has found that each line divided into many lines. So he concluded that each sublevel consists of orbitals. The magnetic quantum number is characterized by: number 1, it's used to detect the number of orbitals in each energy level. Number 2, the sublevel S has 1 orbital. Number 3, B sublevel have 3 orbitals, each orbital which are perpendicular in the 3 direction. So we have P orbital which found in X direction, P orbital which found in Y direction, B orbital which found in Z orbital. The 3 are perpendicular to each other. Also, the electron cloud of each orbital takes the form of 2 pairs, meeting head to head, like a dumbbell for example, at a node point of 0 electron density. D sublevel consists of 5 energy orbitals and F sublevel contains of 7 orbitals. Noted that orbitals of the same sublevel are equal in density and shape, in energy and shape. That means that Bx and By and Bz are equal for the same energy level. Spin quantum number detect the direction in which the electron spins around its axis during the rotation. Each orbital can be saturated by 2 electrons. One of them spins around its axis clockwise, while the other electron spins anti-clockwise. In order to form 2 opposite magnetic fields to decrease the repulsive force between the electron in the same orbital. So one takes ms equal positive 1 and the other takes ms equal negative 1. Let's get a summary about the quantum numbers. The quantum numbers: number 1, the number of energy levels equal the number of energy sublevel. Number 2, number of orbitals within the principal quantum number equal n squared. Number 3, the number of electrons occupied in a certain energy sublevel is given by the rule 2n squared. After that, we're going to talk about the distributing of electrons, the electronic configuration by another meaning. We have 2 rules to configure the electron or distribute the electrons in energy levels. Number 1, of Pow principle or building up principle, which states that the electrons occupy energy sublevels in an ascending order according to the increasing in energy, where the lowest energy sublevel is the first. For example, if we're going to make the electronic configuration for sodium, for example, which is 11, the electronic configuration become 1s2, 2s2, 2p6, 3s1. For calcium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. For zinc, for example, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. The second rule is Hund's rule, which states that there is no electron pairing takes place in a given sublevel until each orbital contains 1 electron. So there is no coupling between the energy level between the electron in the same orbital. Like, for example, if we make the electronic configuration for nitrogen, the electronic configuration you have on the left is correct. Why? Because in 2p we have 3 single electrons. We have 3 single electrons, and the 3 are rotating in the same direction. But the electronic configuration which is found on the right is wrong. Why is wrong? Because the 2p sublevel we have 2 electrons found in the same orbital, and we have an empty orbital, and this is wrong according to Hund's rule. By the same way, the electronic configuration of oxygen, we have the one which is found on the left is correct, because we have 3 single electron firstly, and after that the fourth electron is put in the first one. But the second electronic configuration is incorrect. Why? Because we have 2 paired electron and empty energy sublevel. Don't forget, the electrons are preferred to be unpaired before pairing, because according to Hund's rule, on pairing electron in the same orbital, they will repel, decreasing the stability of atom. Number 2, the electrons prefer to be paired with another electron than transferred to higher energy sublevel, and the energy needed to transfer it to another energy level is high. Number 3, Also, the spin of a single electron must be at the same direction because this gives the atom more stability. After that, we have the electronic configuration to the nearest noble gas. Like, for example, lithium, the nearest noble gas to it, nearest previous noble gas is helium. And after that, we have 2s1. For lithium, for example, for sodium, for example, we have neon, and after neon is 3s1. For potassium, for example, we have argon 18. After argon, we have 4s1. This is chapter 1. This is the end of chapter 1, and thank you.